Now we will use all the informations gathered in previous videos to draw heating curve and cooling curve. To draw heating curve, we will assume that a solid is below its melting point and heat is being supplied to it at a constant rate. If we will supply heat to a solid at constant rate, then first the temperature of solid will rise, that is average kinetic energy of its molecules will increase, and this increase will be only up to a certain temperature called melting point of solid. When solid has attained its melting point, then even though the heat will be supplied to it, but there will be no rise in its temperature. That is, heat supply will be utilized to change its state, that is, to increase intermolecular separations by breaking the intermolecular bonds. Now, when entire solid has changed into its liquid state, then on further supplying heat to the liquid, its temperature will rise, and this time specific heat capacity of liquid being more than the specific heat capacity of solid or vapor state, the time taken will be more. It means this time the graph will be say like this, and this shows increasing temperature with time, but this increase also will be only up to a certain maximum value, and that maximum value of temperature will be the boiling point of liquid. At boiling point, the temperature will remain constant while heat supplied to the liquid will be utilized by it to increase intermolecular separations by breaking the intermolecular bonds, and hence to increase potential energy of molecules. Now, when entire liquid will change into its vapor state, then on supplying heat to these vapors, the temperature of vapors will rise, and specific heat capacity of vapors being less, it will rise a bit quickly. So graph will be like this. If the curve is O, A, B, C, D and E, then from here we can see that the slopes in parts DE and OA will be more, showing that the rise in temperature is a bit quick, showing that the specific heat capacity in solid as well as in vapor state is less. Also, the slope in part BC is comparatively less. Slope of part BC being less, it shows that more time is taken by liquid to change its temperature, that is, specific heat capacity of liquid is more. If we compare the lengths of parts AB and CD, then AB is less than CD, again showing that less time is taken by solid to change completely into its liquid state, while the part CD is comparatively larger, showing more time is taken by liquid to change completely into its vapor state. This again shows that specific latent heat of fusion is always less than the specific latent heat of vaporization. Thus, AB less than CD indicates that specific latent heat of fusion is always smaller than the specific latent heat of vaporization. Similarly, we can draw the cooling curve for a substance. Say a substance is in the form of superheated vapors. It means the temperature of vapors is above the boiling point of the liquid. Say initially the temperature of vapors is at this position, then if we will continuously withdraw heat from the superheated vapors, then their temperature will begin to fall, and this temperature will fall, that is the average kinetic energy of molecules of vapors will decrease until the vapors attain their condensation point. At condensation point, the heat will be continuously withdrawn from the vapors, but there will be no fall in their temperature. Thus, the heat withdrawn will be utilized to change the state. It means to decrease the intermolecular separations, that is to decrease the potential energy of molecules. Now, until the entire vapors change into their liquid state, the temperature will remain constant, and when whole of the vapors change into their liquid state, then on further withdrawing heat, the temperature of liquid will fall. And since specific heat capacity of liquid is comparatively large, so the slope of this part will be comparatively less, means more time will be taken to bring the temperature of liquid from its condensation point to its freezing point. When the liquid will attain its freezing point, then again the temperature will become constant, and at freezing point the average kinetic energy of molecules in solid state will be maximum, while for liquid state this average kinetic energy will be minimum. When liquid has attained its freezing point, then on further cooling the liquid, the change in state takes place. That is, the liquid begins to convert into its solid state, and since the specific latent heat of freezing will be less than the specific latent heat of condensation, so less time will be taken in freezing, and when the entire liquid has changed into its solid state, then on further withdrawing heat from the solid, its temperature will begin to fall, and this time it will fall a bit quickly because specific heat capacity of solid will be less. If again we are naming the curve as A, B, C, D, E and F, then slopes of AB and EF will be comparatively more, showing that specific heat capacities in vapor and solid state are less, while the slope of CD will be less, showing more time is taken to change the temperature in liquid state, that is specific heat capacity of liquid state is more. Also, part D is less as compared to the length of part BC, showing that more time is taken for changing the state from vapors to liquid, that is the specific latent heat of condensation is more, and specific latent heat of freezing is less because less time is taken by the substance to change into its solid state. It was all about the heating and cooling curve. Now we will apply the principle of calorimetry and our knowledge of change of state to solve the numericals related to calorimetry. Say the first numerical is to determine time taken by a heater of power 400 watt to convert 40 gram of ice at minus 20 degrees Celsius into superheated steam at 120 degrees Celsius. Here we must know that in what way heat is utilized by the ice after absorbing from the heater. First, its temperature will change from -20 to 0 degree Celsius. We will be using MC delta T. After coming to 0 degree Celsius, it will change its state, and for change of state we will use ml. After changing its state, it will form water at 0 degree Celsius, and then that water at 0 degree Celsius will increase its temperature from 0 to 100 degree Celsius. So we will again use MC delta T. After attaining its boiling point, water will begin to boil. It means again change of state will be there. So we will be using ml. When steam is formed, then that steam will increase its temperature from 100 to 120 degrees Celsius, and for that we will use MC delta T. If we are saying that the time taken by heater is T, then heat supplied by heater to the ice will be power into time. Power is 400 into time is T second. So this will be the heat supplied by heater to the ice. Now the heat absorbed by ice, that will be mass of ice is 40 gram, so M, and specific heat capacity of ice is 0.5, while change in its temperature from -20 to 0 degree Celsius, that is 20 degree Celsius, plus now this ice will melt, and for melting, mass into specific latent heat of fusion, and mass is 40 while specific latent heat of fusion is 80 calorie per gram, plus now this water formed due to the melt of ice will increase its temperature from 0 to 100 degree Celsius. So mass is 40 into specific heat capacity of water is 1 calorie per gram per degree Celsius, and change in temperature of water will be 100. Now water has attained its boiling point, so the boiling of water will take place, and for this boiling we will use mass into specific latent heat of vaporization. Mass is 40 while specific latent heat of vaporization is 540 calories per gram. Now this steam formed will change its temperature from 100 to 120 degrees Celsius. So MC delta T, M40, and specific heat capacity of steam is same as that of ice, that is 0.5 calorie per gram per degree Celsius, into change in its temperature is 20. And on RHS, heat will be in joule if time will be in second, but here on RHS all these heats are in calorie. So to convert all these heats into joule, we will multiply this expression by 4.2. Now this implies T is equal to, we can see that 400 can be taken as common from all these terms, so 400 will get cancelled, and we will get 1 plus 8 plus 10 plus 54 plus 1 into 4.2. This is equal to 74 into 4.2 second. This is equal to 310.8 second. Now come to the second question. This second question states that through a jet of steam, 50 gram of steam at 140 degrees Celsius is made incident on a block of ice. The dimensions of block are not given, so we will assume that the dimensions are large enough. It means the steam will be unable to melt the entire block of ice. Determine the final amount of water in mixture. Here heat will be lost by steam and will be gained by ice. Now in what way the steam will lose heat? First, steam will change its temperature from 140 degrees Celsius to 100 degrees Celsius. After that, it will condense, forming water at 100 degrees Celsius, and then that water at 100 degrees Celsius will give heat to the ice to change its temperature from 100 to 0 degrees Celsius. If we use the principle of calorimetry, then heat lost by steam must be equal to heat gained by ice. And if mass of ice melted is m gram, then first steam will change its temperature from 140 to 100 degrees Celsius. So mass of steam 50, specific heat capacity of steam is 0.5 calorie per gram per degree Celsius, into change in its temperature 140 to 100, that is 40 degrees Celsius. Now the steam at 100 degrees Celsius will condense into water at 100 degrees Celsius, and for this process the latent heat required will be mass 50 gram into specific latent heat of condensation is 540 calorie per gram. Now this water formed at 100 degrees Celsius will lose heat to decrease its temperature up to 0 degree Celsius, that is equal to the temperature of ice, and for that mass into specific heat capacity of water is 1 calorie per gram per degree Celsius into change in temperature, that is 100, and all this heat supplied by steam will be absorbed by ice only to melt, because the final temperature of mixture is only 0 degree Celsius. So the mass of ice melted, that is m gram, and specific latent heat of fusion of ice 80 calorie per gram. This implies 8m is equal to 100 plus 2700 plus 500, implies m is equal to 27 and 5 32 3300 by 8, 412.5 gram. Thus 412.5 gram of water will be formed due to the melting of ice from the block, while 50 gram of water will be formed due to the condensation of steam. So total amount of water in mixture will be 412.5 plus 50, that is 462.5 gram. In this way we can determine the total amount of water in the mixture. Let us take one more example related to calorimetry. Say a person can chew 40 gram of ice at minus 20 degrees Celsius in 1 minute 20 seconds. Then taking the average temperature of person to be 40 degrees Celsius, we have to determine power of that person. For solving this question, first we will understand in what way the person is supplying heat to the ice. The ice is at minus 20 degrees Celsius, so first person will have to supply heat to the ice to bring its temperature from minus 20 degrees Celsius to 0 degrees Celsius, and at 0 degrees Celsius the person will supply heat to the ice to melt. After the ice has melted, the person will bring the temperature of that ice melted, that is the temperature of water formed due to the melt of ice, from 0 degrees Celsius to its own temperature, that is 40 degrees Celsius. Hence there will be change in temperature in two parts, so we will use mass into specific heat capacity into change in temperature for those two parts, while in one part there will be change of state, so we will use mass into specific latent heat to determine the heat exchanged. First, for changing temperature from -20 to 0 degree Celsius, heat supplied will be mass and 40 gram. Specific heat capacity of ice is 0.5 calorie per gram. Into change in its temperature, change in temperature will be -20 to 0, that is 20 degrees Celsius, plus change of state, mass is 40 gram, specific latent heat of fusion of ice is 80 calorie per gram, plus change of temperature from 0 to 40 degrees Celsius, mass is 40 gram, specific heat capacity of water is 1 calorie per gram per degree Celsius, and into change in temperature of water from 0 to 40, that is 40 degrees Celsius. So it is the total heat supplied by man to the ice in calories. We will convert it into joule by multiplying it with 4.2. This is equal to, if power of person is P, then power into time will give the work done by person, that is the energy supplied by person to the ice. Power and into time is 1 minute 20 seconds, that is 80 seconds. So this implies power of person P is equal to 40 can be taken as common, so it will be 20 into 0.5 10 plus 80 plus 40 into 4.2 divided by 2. Both sides are divided by 40. This is equal to, it will be 130 into 2.1, and this will become 327. So 273 watt. It will be the power of person. If you think this video is of any help for you, then please share it with your friends so that they may also be benefited by it.